Hello and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy, and today we're going to look at ways you can improve your supply chain security and better protect yourself from hidden threats that often emerge as a surprise when vulnerabilities are disclosed that you didn't even know you had. As always, please follow us on LinkedIn and make sure you subscribe so you can always get the latest updates. In cybersecurity, there's a lot of different threats that you have to deal with. Most of these threats have been around for a long time. Examples such as spear phishing, business email compromise, or web application attacks have usually been around for over 20 years. The good thing is when something has been around that long, you can build some good defenses. Will these defenses work every time? Probably not, but there's always a cat and mouse game of how attackers can craft the next tricky thing. But there's some best practices that stop 80 to 90% or maybe even more of attacks. Today, we're going to talk about software supply chain attacks and what you can do about them. There are a lot of ways software supply chain attacks can go badly on you, and there's a variety of things that you can do to protect yourself. So listen up, and hopefully we can share something with you that maybe you haven't heard before. All right, let's start at the beginning. Most organizations hire software developers to write software. Right? We use software for things like our corporate websites, customer relationship management, financial accounting, human resources, etc. Now, to build software, you really make a choice early on. Do we want to build it from scratch or do we want to buy it? Mostly, you need to consider the total cost of ownership to make an effective decision. And that usually means for any product, we should calculate the price of the software licenses, plus the price of development, and if we're doing developers ourselves, probably as much as $200,000 or more per year per developer with a fully loaded labor rate. And then the price of hosting the infrastructure, which adds up the total cost. Well, let's take an example of this. Your organization needs to provide financial accounting software to the chief financial officer and her staff. You have two estimates. You can buy something like QuickBooks Online for $50 per user per month, or you can custom build an app. Now, knowing that recreating QuickBooks from scratch is going to take a number of developers to build, it will take probably years to create. In this case, the choice is pretty clear. Now, sometimes you want to build something custom. This could be a software product your company sells or your public website. Now, when you go down this route, you have to decide how much custom software do you really want to build versus how much can you reuse from others. I mean, everybody reuses something. Common examples of things that are reused are programming languages, operating systems, runtime environments, middleware, web frameworks, and so on. The trend over the last decade has been to use free and open source software, commonly known by the acronym FOSS or FOSS. FOSS minimizes time to recreate things and avoids licensing costs, which most people hate paying anyway. The big problem is that not all software is maintained properly. Commercial software vendors are incentivized to keep the software modern and secure since that's how they make their money. Open source is a bit of a different story. Some open source software is maintained by a single developer who gets tired of user complaints or wasting her time on new features versus watching maybe the latest show on Netflix and wants to move on to writing something completely different. So frequently, open source software starts to age without being updated. Additionally, many developers are good at writing software, but have yet to learn all the different types of ways that hackers can defeat the design intentions of an application. So they perform a free static application security test, or SAST, but never try other security testing tools like dynamic application security testing, or DAST, or software composition analysis, or others. And additionally, if the software is built by a college-age programmer, the developer may not have actually spent money to review the software of the commercial tool. Most free SAST and DAST tools lack features found in their commercial counterparts. Hopefully, you see what we're getting at. Open source software has multiple ways that it can become vulnerable. Let's say there's going to be another massive vulnerability in open source software like Log4j or Heartbleed or OpenSSL. It's going to cause you a big headache. So let's talk about 6 important steps that you can do right now to secure your organization. Number 1, you need to centralize your software code repository. You don't want to have to check github.com, 100 private GitLab repositories, 25 Bitbuckets, and maybe 20 AWS code commit locations. You want everything to be in one software code repository. And then if someone asks, hey, do you have XYZ software in your organization? You can say, well, let me do a quick search and see if any software repositories return a result. Also, make sure your software code repository ties back to ownership. You should be able to determine who owns each software repository and is responsible for maintaining the code. This person, who hopefully is still in your company, can make the call to remove software that's outdated or even updated. So number 1, you need to centralize your software code repository. Number 2, you need to centralize your artifact repository. Solutions such as Artifactory or Sonatype Nexus provide a location for you to host all of your binaries, containers, and executables across your organization. Now remember, if developers can go externally to download software whenever they want versus using an approved software update from within an approved source, then it's just a waiting game until a developer downloads code that's preloaded with hidden malware or even a crypto miner. Ensure there's a mirror in your artifact repository of every Node Packet Manager, or NPM, Java, and Red Hat library running within your own network. This allows you to gain important insights from a security perspective. When a piece of software is identified as bad, you can say not only do we have this library within our artifact repository, but we also know that it has been downloaded 1,000 times by developers. And additionally, if you want to remove it from the organization after you're sure it won't break the software of others, this is the one place that you can do that. Okay, centralized software code and artifact repositories. Number 3, you should scan open source software for malware. I mean, if somebody you didn't know emailed you an executable, would you just double click it? Hopefully not. But if you thought that there were an important business reason to see the executable, then you should at least scan it for malware. And the truth is that most software organizations don't do this. We're not talking about email attachments, of course, but we're talking about open source software. As a CISO, you should see if the artifact repository solution used by your organization has 2 types of malware scanning. First, does it check for malware before adding open source software to its holdings? And then secondly, does it have a recurring scan to identify if malware is within its holdings when malware signatures get updated by the antivirus software? This will minimize crypto miners and other harmful malware from staying in your organization. Now, here's one way that you can build a secure pipeline for malware scanning. Take open source software that your developers want to use and put it in a public S3 bucket with read-only access. Then use VirusTotal to perform a URL scan on your S3 bucket. This allows you to scan open source software with over 50 different antivirus tools. And since AV software is known to have false positives, you might set a threshold that says if 3 or more of the 50 antivirus vendors flag this as malware, then we will not allow the software to enter the company. Okay, we've centralized our software and artifact repository and scanning our open source software for malware. Number 4, scan your software for vulnerabilities and vendor support. One of the biggest problems today is developers leveraging software with known vulnerabilities. This could be because there's issues with running the latest version of software, or there's no patch for an XYZ vulnerability since it just came out, or we didn't even know that newer software exists. Most organizations will purchase software called software composition analysis software. Okay? Vendors like Black Duck from Synopsys or Snyk, or spelled SNYK, or GitHub's Dependabot will scan your software repositories, identify both direct and indirect dependencies, and flag those with known vulnerabilities. Let's say you're using a particular library that's version 1.3. And if you did some independent research, you might discover it contains 2 critical and 5 high vulnerabilities, and these have been fixed in subsequent updates. The software tools will advise you should update your library to the latest version, let's say 2.1. Now, this is helpful information. Developers can put this into a continuous integration pipeline with tools like Jenkins or GitHub Actions that check all software for vulnerabilities. Now, if you see a higher critical vulnerability, then please break that software build and don't release it. Guess what? If Log4j gets a critical vulnerability or a CVE score of greater than 9 assigned to it, then your developers will get timely feedback that they need to update as soon as possible since they can't release their build. Don't think this can happen to you? According to the Wall Street Journal, As recently as the 9th of February, 2022, Sonatype observed more than 9,300 downloads per hour of older versions of Log4j that did not have the security update that was created in December. That's not downloads since December, that is an hourly count. The one thing to understand here is that just because there isn't a public CVE doesn't mean the software is flawless. There's a lot of software that doesn't have support from a vendor. Developers should use tools like the versions plugin for Apache Maven if writing Java code to detect if the dependencies are the latest version, or if there are dependency updates available. You can do this manually at search.maven.org, but a better way is to run Maven versions display-dependency-updates command. Now, this is super important. Let's say a software company has a huge bug in their software that gets patched. And in the release notes, the company says, bug fixes. You don't know if the bug is a software vulnerability, a memory leak which could crash your app, or something else. Plus, new software often has new features which you can put to good use. So please stay current because software ages like milk, not like wine. Tools like Maven Versions will tell you how far every Java library that you declare in your software bill of materials is from the latest version from the vendor. Okay, so we're going ahead and we're centralizing our software code, our artifact repositories, our open source is scanned for malware, our software is scanned for vulnerabilities and vendor support. Number 5, run a web app firewall or a WAF to quickly patch your organization. Let's say you have 100 development teams that run a piece of vulnerable software such as Log4j. Your cybersecurity team has to track the status of 100 teams to identify when they are all patched to ensure the organization isn't vulnerable. And in this scenario, you're only safe when your slowest dev team finally is patched. And this could be weeks or months. Now, enter the biggest benefit of a WAF. If every application sits behind a web app firewall, then you might only have to make a change to the WAF to block the Log4j vulnerabilities on all applications. Now, this means you can secure the organization quickly and give the developer some breathing room when the fix takes longer to patch than the time it takes for an exploit to be released. And finally, number 6, run a Runtime Application Security Protection, or RASP, tool. Now, one of the best features of a RASP is it can inspect software for application libraries. Remember this, vulnerability management tools like Qualys and Nessus will miss finding custom applications containing Apache Struts vulnerabilities, for example. Now, it's true that software composition analysis, or SCA, and container scanning tools can find application libraries. However, there are things those tools don't have that a RASP does. They don't tell you if the vulnerability in the vulnerable library is actually in production. You only know if the vulnerability is in your code. RASP is used on production boxes, so a hit confirms an active vulnerability. You can quickly query RASP technologies to obtain an accurate software inventory for application libraries used on the same box as a RASP agent. RASP actually protects software, unlike the software composition analysis or container scans, since it has a built-in web app firewall. Finally, RASP has another amazing feature. RASP can actually look into the binaries and tell you what libraries they're running. This is super helpful when looking at vendor software. Let's say you host financial software on your own servers. You can install a RASP agent on the software and look at application libraries the financial software is running. You could find out if Log4j or OpenSSL were being used by these vendors, and then reach out to the vendors and ask for a patch. If you didn't have RASP, you'd probably be flying blind unless the vendor publicly discloses that they're vulnerable or provides a software bill of material. Now that you know the important steps you can take to defend your organization, let's talk a little about where the industry is headed. There's a new industry collaboration called the Supply Chain Levels for Software Artifacts, or SLSA, pronounced salsa, whose URL is slsa.dev. This organization is led by a vendor-neutral steering committee from Citigroup, Cloud Native Computing Foundation, Google, the Linux Foundation, Intel, VMware, Datadog, and ChainGuard. According to their website, SALSA is a, quote, security framework, a checklist of standards and controls to prevent tampering, improve integrity, and secure packages and infrastructure in your projects, businesses, or enterprises. It's how you get from safe enough to being as resilient as possible at any link in the chain, end quote. SALSA specifies levels of incrementally adoptable security guidelines, with SALSA 4 representing the ideal end state. Let's take a quick look. Level 0 is basically no guarantees. Open your mouth and close your eyes. I have a surprise. Here comes your software. It means there's basically no SALSA safeguards in the enterprise. Level 1 is documentation of the build process. At level 1, the build process is fully scripted and automated and generates provenance. Now, provenance is metadata about how an artifact was built, including the build process, the source code, and its dependencies. Level 2 is tamper resistance of the build service. Level 2 is achieved by using version control and a hosted build service that generates authenticated provenance, meaning that any tampering would invalidate the provenance assertion and alert the programmer. Level 3 offers extra resistance to specific threats. Both the source and the build platforms meet auditability standards for source and integrity. This would involve an accreditation process whereby auditors certify that platforms meet requirements, perhaps similar to having like a SOC 2 Type 2 report or an ISO 27000 assessment from an outside auditor. And level 4 represents the highest level of confidence and trust. This top level requires two-person review of all changes and a hermetic or airtight reproducible build process. Similar to moving money for a bank, a two-person review is an industry best practice for catching mistakes and bad behavior. It greatly increases the likelihood that any software tampering would be detected. Now, with these 4 levels, SALSA is trying to raise the bar against supply chain attacks. Now, realize that most organizations haven't done these steps, but we can see how they would help in the future. Let's look at some examples. If someone submits bad code to a repository, a two-person rule might catch the vulnerability. If an attacker injects malicious commits into a source code repository, then having software show that it wasn't signed by the developer can be a big indicator for untrusted software. And if software is altered during the download from a website, having signed packages could also help to say, this isn't from the developer you think it is. There's really a lot of opportunity for our industry to improve here. We think that this work coming from SALSA is going to be important and influence standards from the federal government. But if it's not as actionable today as the previous 6 steps we mentioned, frankly, if a company such as SolarWinds is hacked and they push out signed updates that contain hidden malware, there isn't a lot that companies can do to identify this package as bad without extensive testing, which is really impractical since we're talking about compiled binaries without access to their source code. The most effective option is checking software with antivirus tools. However, let's play that out with a real-world scenario. Let's say we've been using SolarWinds for 10 years, and the package trips an alert on our antivirus for the first time. The antivirus says, the software beacons out and it sends data externally. Well, yeah, that's by design. So why is this malware? Are you going to go back to the vendor and have them double-check their software? We all know that many vendors have a history of not committing to real dates and just saying, yeah, it's fine, you can run the software. Now, what happens if your AV doesn't flag it and you have a false negative? See, there's a lot of ways where it's just really difficult to implement software security effectively. Now, in lieu of this, I think we have to be realistic and say, if we can't stop supply chain attacks 100% of the time, then how could we quickly remediate them when they occur? Now, have you actually worked with your cyber incident response team to create an incident response playbook that identifies all the steps you need to follow to remove software and declare the malware has been remediated? If not, it's a good thing to start considering. Remember that safeguarding an organization means working through multiple steps. For example, the NIST cybersecurity framework has 5: identify, protect, detect, respond, and recover. Have you identified all systems where you think you are vulnerable? Can you protect or stop the event from occurring? If you didn't stop the attack, could you detect when the attack occurred? Can you respond to minimize impact? And can you recover to fully restore your services? One great way to think of fleshing out these defenses can be found in the OWASP threat matrix and safeguard matrix. And that's going to be in our show notes. It's owasp.org/www-project-threat-and-safeguard-matrix. Should probably come up with a shortened URL for that. Okay, so let's wrap this up. If your organization develops applications, they most likely depend on external libraries and dependencies. So remember to implement these 6 steps. Number 1, centralize your software code repository. Number 2, centralize your artifact repository. Number 3, scan open source software for malware. Number 4, scan software for vulnerabilities and vendor support. Number 5, run a web app firewall. And number 6, run a runtime application security protection tool. We appreciate you being a listener to our show and wish you only the best in stopping these types of attacks. Now, if you learned something today, please reach out to us at CISO Tradecraft. You can connect with us on LinkedIn or just drop us a comment on CISOTradecraft.com. We'd love to hear how you're taking your CISO Tradecraft to the next level. Also, if you have an idea for a future show you'd like us to talk about, have somebody you'd like us to host, let us know. We'd love to help you. Thanks again for listening. Again, this is your host, G. Mark Hardy, and until next time, stay safe.